we're going to switch to the next. Okay, here's your design, and the time is starting. You got to design an L-shaped bracket for SR 404, and it should be 2 inches above. And guys, this if you're not familiar, this is what an SR 4 looks like. So it's got 2 little round things sticking out the front. Okay.
30 seconds.
Yeah, you guys hurry up, man. Draw, draw, draw. I want to see these in the air. Yeah. Just draw it on there. Yeah, it doesn't matter. It's yours. You know, you're doing it. So I just want to see what you guys come up with. Oh, it's already. Let's. I'm going to actually extend it to a minute because I see some of you guys are having some issues. Okay. Quick, guys. You're doing this quick. This is back. This is back. No, this is back of the envelope. Come on. Rough is rough. Is good. Okay. Okay, everybody. All right. Okay, I'm going to call time. Now we're going to move to the next one here. Come on. Okay, now when you look at your drawing, does it look like the 2D approach or does it look like the 3D approach? There's another possibility, but I'm not going to talk about it. Which one did you most draw? Look at it. Okay, now a lot of you guys are doing 3D. Now, some of you probably do 2D. All right, now if you're doing 3D, I'm going to show you an approach that is really more 2D that gives you 3D. And that's one of the ways you approach your 3D designs. So what I'm trying to say is that if you're using this particular approach, you may not, the 3D approach, is there a cursor on there? No cursor on there. Okay. If you're using the 3D design, you might find alternative programs easier for you to conceptually do. Okay. If you did this, you're going to fall right into the Design Spark Mechanical's strengths will take you. Now, does that mean you're not going to do 3D design? No. It's just the way you perceive the problem when you're doing your back of the envelope style things. All right. So we're going to take Paul's Pendulum challenge, and we're going to first check. We'll come back to this slide. On your desk, everybody should have this drawing on the front page. Okay. So if you have Design Spark Mechanical installed, if you don't, this is the link to it. But if you want to follow along, you have to have Design Spark Mechanical and an account. Okay, everybody's on start page. All right, so like I say, if you have the start page, close it. You don't need it. All right, now file. We're going to open a new one, and this is the design. Okay. Now, it shows you immediately into a 2D screen. You see this arrow with an eyeball? That is essentially the plane view. So if you hit that, you're now looking at the plane straight on. Okay, now we're going to go up here into this area right here. These are sort of your tools in your sketch stuff. You have a couple of really important ones. You have 2-point square rectangles, 3-point rectangles, 2-point circles, 3-point circles, multi-sided polygons, And though there's some other ones, this one here is a point, which can come in handy. And another thing that you have is line and this line. This is a construction line. Very useful. All right. So like if we go look at Paul's design, we can use construction lines to build the whole thing. His overall length is 50. So I can do a construction line, half of that value. Okay. And I can go the other half the other way. Okay. So I have two construction lines. I can go to the top, and his is 25. So I can go 12 and a half. And I'm just using this construction line. 12 and a half this way. Now, there's two things that I'm doing here. I'm using construction lines, and I'm also not trying to draw this with my mouse. You don't even none of the CAD programs you want to be using your mouse to set dimensions. You always want to set dimensions from whatever dimension box they offer. In Design Spark, they make little boxes, and if you watch it one more. So if I go from here, if I grab this rectangle and now go from here to here, I've got my initial base box. Now, you could say, well, why? Yes.
So if you've already drawn it, how do you adjust the dimension? How do you type into the dimension? If you select one,
once you hit enter, it's that object is set.
and you can't change the dimension.
You can't, well, you can do it in the 3D view, but if you're doing it from this approach, it's usually easier to just hit Control Z and start over. Otherwise, that'll move you back one step.
I guess
Hey, Doug, very much.
You can ask, well, why did you use the construction lines when you could have just drawn a rectangle? You can. If you do that, you check this define rectangle from center. Okay, you can just check that and do it. But I'm going to use I'm taking you from a very simple beginning point of view. So we're going to use construction lines. All right. So now, if you look at Paul's design, he has a block at the top of it that's 9 millimeters. So we're going to go back to construction lines, and we're going to hit here and go down, and we're going to hit 9. And we'll go to the other side. You don't really need to do the other side because we can just do this. Okay. Now, I probably wouldn't have should have used the construction line there. I should have probably used the line. Okay, here we go. So now we got the line. So now we have his 9 millimeter box there. Well, now, if you look at his dimensions, it's not absolutely clear exactly how wide, how much. He's got an R5 and an R6. All right. But I'm going to assume that the second part, the part that's on top, is 10. And I'm going to say he gave it a tolerance of 1. Okay. So that it was 11. So if you have 25 minus 11, you have, you could, excuse me. So I'm going to start and draw a circle here that is 11. Oops. First of all, I'm going to hit Control. Sorry.
Hardly anybody has the CAD software up because it's impossible.
Wouldn't it be 12 though?
Okay. All right. Wait a minute.
If it's R6, the diameter is 12.
Well, okay.
Yeah, if the radius is 6, the diameter would be 12.
Okay, so I just set it at 12. But if you look at, all right, so now at this point, then at 10 down, so we can have our construction line of 10 down. Okay, that's where he's going to have, it looks like I want to say that he had a circle, that's where he had a 3mm screw. Well, we're going to find that we'll just draw it at 3mm for now. Oops. Wait a minute. Okay. Okay. All right. So that's his bottom part in a 3D point of view. All right. Now there's an interesting, you want to make sure you're in select. You can use one very handy shortcut, keyboard shortcut is Shift, middle button, and drag. That allows you to pan your part anywhere you want. All right. Okay, now it looks like I didn't draw that one line. Well, let me go here. All right. Okay, so if we go to 3D, you can hit this button over here, which gives you the what do you call that? Trimetric view. So it's not, again, exactly sure how Paul had this originally designed. So, but if you notice, you go over the different areas, they're now where they're intersected, you have different regions selected. So I can grab a section and use the pool tool. Pool tool and go up, and I'm going to pick a number. I'm going to go 3. Okay. And I'm going to take this guy and pull it up to 6. Okay. Now that's a little, again, I don't know exactly how Paul had it done, but we're going to want these things up, this and this. And you use the control button to select multiple areas. You're going to want to pull that up. Now here you can use this button here and pick an area, and it'll pull it right up to that area automatically. All right. So now, essentially, this is Paul's part, bottom part. Now, you can either draw the second part on this if you wanted to, but it's often easier to just create a new design. Okay. Hit your little button on with the eyeball on it. Now this time we're going to, instead of using the construction lines, we're going to define the rectangle from center, and we're going to go up to it's going to be 10 on this dimension. Then you hit the tab to go to the other dimension, and it's going to be, no, it's not 50, is it? Yeah,
40, it's 45. The square part of it is.
Oh,
45? Okay.
Not counting the half circle at the top.
Right. Okay, so you
Right,
hit
'cause it's-
hit 45, hit enter. Okay. Then you go to the select your circle tile, go into the middle, and just make that 10. Then in the middle, you're going to do 3.175, I think he's got. Okay. All right. Now, hit your side view. All right. We're going to move this guy and oops. We're going to hit select. Oh, wait a minute. I'm going to put it in 3D mode. Hit select. Do cool. Up to 3. And then on this guy, we can spin it. And we can select this one and this one. Oh, it looks like I undid that. We can do a pull and just do that 3. Okay, so then you have the second part. Now, you can bring this, you can always do over here on the solid. Now, you did notice you have you still have a surface, and that's where the little circle in the middle is. So you could just delete that. So now you just have the solid. You can copy it, and you can bring it into your other design. Now, you're going to have to move it, and we're going to move it down to there. Oops. Okay, and then we're going to move it up. Move it up. And I'm going to go 3.2. I don't just, so it shouldn't be touching anymore. Let's see. Yeah, you can see there's a little, well, I don't know. You can see there's a little gap there. All right. Now, you can say, well, this guy doesn't match this guy anymore. I want him to be flush with that. Well, you would hit the pool tool. It will select, hit the pool tool, and you grab this guy, and then you hit bring it up to, and boom, it's now brought up the extra 2/2 of a millimeter. All right. Okay, so there you go. That's Paul's design, except for one thing. Paul also asked for a screw. He wants to put a screw into this thing. So I'm not going to show you that here right now, but I'm going to show you how to do screws so that you can see that. All right. So first of all, I'm going to go ahead and make this smaller. And okay. Okay, let's see that. Okay. Go to 7. So before we move on, I want to show you the screws. This is how to start. So here's general CAD suggestions. 1, start in 2D view. Use construction lines to lay things out. Never try to set your dimensions with your mouse. always use the dimension boxes. If you're going to 3D print, you need to consider strong and weak axes of the print, but we're not going to get there yet. And you also should remember to use appropriate materials. Not everything has to be 3D printed. All right, now I told you I was going to talk about screws. All right. This is how you can calculate the cutter for a screw. This is not Design Spark Mechanical Limited. This would work with any CAD program. All right, so essentially you create a rectangle that has the height of the pitch, and that's the pitch thread pitch, and the width of the pitch minus 0.5. That's what this guy is right here. The R1 and R2 somehow got shifted. Then R2, which is this rectangle, you want to have the same height of a pitch, but you want the width to be the pitch times 0.3333. Okay? Then using this location right here, you want to form an equilateral triangle, and the R2 width should be R2 width times 2. Okay, that's from this point. Now, I've shown the measurements for an M3 screw and a 6/32. These are about the smallest threads that you can do on an FDM printer. Okay, but you can do those threads sufficiently well that you don't have to, okay, is that you can screw the thread in without using a screwdriver or anything. It is possible to do these with an 8-year-old 3D printer. So with the new ones, I'm sure you can do it too. All right. So now, so if you're making a bolt hole, you're going to use the tap drill size. And where do you get the tap drill size? You get that from a chart. Okay. And then you subtract, huh?
I said, if you work TI, the little blue book that they handed out.
Yeah. I'll hand out, here you can see, here's another picture of this. And here's a typical, the one I'm showing you here is metric thread dimensions, and you can just pass these around. And this is a calculator which can do imperial threads, and you can do them in millimeters. So that makes it just like, quote, a funky metric thread. So I'll pass these out for you guys to look at. And those links are going to be here in the next slide.
Yeah, and if you don't have it on a piece of paper with you because you're somewhere else, you can go to Google Images and type M3 drill chart or tap chart, and it will give you everything you need to know.
These are the three links that I go. Now, how to make metric thread, this YouTube channel right here, that's the one that's, let me put it this way. If you go out and you say, well, how to make threads, it doesn't matter whether it's Fusion 360, Design Spark, all different programs show you how to do this, but they don't give you standard threads. This method I'm showing you will give you standard 60-degree metric and imperial threads. Okay, and this guy will show you how to do it. And the nice thing about this is what the cutter looks like when you get finished through the procedure. You can see that here's R2, and this is the triangular part truncated at the end of R1.
That's what this was supposed to be, right? That shows you that triangle truncated.
Yes. Yeah. Okay. So this is now the nice thing about this is what you do is you open up you design a cutter for whatever particular thread you're cutting, and you save the cutter, then the cutter can be used in any other program, or excuse me, any other project. You don't have to keep doing this every time. You create the cutter. It's just like creating your own tap or die, and you save it, and then you import it into your project and you cut your thread. Okay. All right. So,
Hey Doug, can you explain cutter? Can you explain cutter? Is it a concept? Is it a thing? Is it a program? What do you mean when you're using the word
I
cutter?
can't, Paul, for some reason, you always come over garbled up. Mark, can you tell me what he's saying?
What's a cutter? Ask them to explain what cutter means. Is it a thing or a concept?
Is it a theme or a concept?
I mean by cutter.
I think what he's not showing you is that you then take this piece and you do a helical
We're going to do that.
spiral.
Yeah, I'm going to do that, but I'm going to do that next. Okay. What I'm trying to say is that the thread cutter is just like a tap and die. You can construct it for any CAD program you're using, keep it as a separate project, and then import it into your other project. But I wanted to show you one that it's easy to use. Okay. You know, what we've done so far, we've essentially used construction lines, we use rectangles, we've used lines, and we've used circles. Then we've pulled them to where we wanted them to be. And we use the move tools to position them. Okay. All right. So I'm not going to go, I'm going to skip over the thread part, but you could easily thread this. Now, so Doug, you say that, but I don't believe you. Look at that YouTube video that's on that list. He will show you how to make the cutter step by step. You've been introduced to the idea of how to make a cutter. You should be able to make that cutter and save it to a separate file.
On Shape is a cloud-based CAD system. It runs in a browser, like I said. Once you've set up and are looking at it, you basically you have a list of documents that you can create. I've created a lot of documents here, but this is the one I just created. This one, DPRG demo. So you should probably look at it like an intro to On Shape to figure out sort of how to navigate around and stuff.
To have that program downloaded.
So On Shape basically only has one view. There's only one view here, and you basically just change how you're looking at it. So it's a 3D view, but you can click on here and say just look at the front, or you can do different things. The idea here is you're creating what are called sketches, and a sketch is like a two-dimensional drawing, just like what Doug did with Design Spark. And you create those sketches on surfaces or planes. So, and I'm using my mouse wheel to zoom in and out here, and you right-click to drag the window around. And so I'm going to click on the top here. I'm going to right-click, and I'm going to say New Sketch. And so that basically creates a new sketch that a two-dimensional drawing, if you like, and you can see that it's in the same plane as the top plane. And then I'm going to hit P, which makes the planes disappear. It just hides them. You can show them individually if you like, to see them, but we don't need to see them while we're doing drawing here. I like Onshape because it is a very minimalistic view here. So pushing N makes you perpendicular to what the sketch plane that you're drawing on. So we'll do the pendulum thing since it's the same sort of thing. With On Shape, you have different kinds of rectangles. So you can do a corner point rectangle or a center point. So we'll just do a center point. We'll put it at the origin here and we'll draw a thing. It doesn't matter what size it is right now. On Shape uses dimensions and constraints. So I hit D, which is the same as clicking this icon right here for dimension. And now I'm going to click on this line and I'm going to say that's going to be 50. And then this one is going to be 25. So now those are constrained to that size. It's similar to what Doug did, but not exactly the same. Constraints are more general than that. They allow you to, I could make another rectangle over here somewhere, and I could constrain this line and this line to be the same length. And, I could constrain, say, this point and this point to be in the same horizontal plane, so that they're in line. And now, I can drag this around, but it won't move up and down because I've said these have to be that far apart. These are on the same plane. Anyway, we're not going to worry about that right now. I'm just going to delete those because we're going to do this part here. So the way I would approach this is you have a circle in the middle here, which is down 10 millimeters. So one of the things you do with On Shape is you put your cursor somewhere and then you just move it, and it gives you a dotted line, and it basically maintains a vertical or horizontal constraint with where you started from. So all lines have midpoints, and I can put the mouse here without clicking and just draw down. And now this point is constrained vertically, or well, horizontally, I guess, with that midpoint. So now I'm going to draw this circle, and it doesn't matter what size you make the circle because we're going to change it. But one of the things that we know is that the center of this circle is 10 millimeters from that line. So I'm going to hit D again to go to dimensions. I'm going to click there and I'm going to click here, and that's 10 millimeters. And then I'm going to say, okay, well, the other thing we know is that this outside one has a radius of 6, which is a diameter of 12. But really, I don't really want a circle here. I really only want half a circle. So I'm going to go over here and click, and there's different kinds of circles, but we want a center point arc, which is one where we're defining where the center point is. So once again, we go to the center point here, we drag down a bunch, and we click there, and then I'm going to move over. And once again, it doesn't really matter how you do this because we fix it afterwards. So I'm going to take these 3 points here, and I'm going to say they all have to be horizontally constrained. So this is now exactly half a circle. Once again, I'm going to take this point and this line, and I'm going to say those are going to be 10, and this guy is an R6. And so now I've got a half circle exactly where I want it to be. And you can move these dimensions around so that they're not messing up the drawing. So now I'm going to take a line, and I'm going to start from here, and I'm just going to drag it over to that thing. And I hit escape to stop drawing, and then I'm going to draw another line, L for line. I'm going to click here, and I'm going to go sideways. And if you're, you can draw it, but if you're near a particular constraint point, so it'll constrain it horizontally or vertically, and you can see because it changes to sort of a dotted line there. And then it also constrains, when I click there, it basically constrains this point to be on this line. And the neat thing about that, if I say, you know what, I don't really want it to be 25, I really want it to be 30. And you see these lines went out because we're not defining the length of this line to be something. We're defining that the end point of this line, which is a vertex, is constrained to lie on this line here. These two things are constrained together. And so if I make it 20, then it doesn't matter what size you make it. And that's one of the cool things about a constraint-based system. It takes a little while to wrap your head around it. So the other thing, you know, Doug spent a bit of time there talking about threads. I print in ABS, and I don't ever model threads in my CAD. What I do is I print an undersized hole, which is the size that the drill chart says should be basically the tap size for this, you know, for an M3 screw. And in that case, it's 2.5 millimeters for drilling or for tapping plastic. So I just make a 2.5 millimeter hole in this case. So now we're still in, you know, you can still drag this around and look at it and whatever. So I'm going to grab this piece here, and I'm going to hit Shift E, and that means extrude. And that's almost exactly the same as the pull operation that Doug did. And I'm going to say it's going to be 3 millimeters. Okay, boom. So now my sketch auto hide, so I'm going to unhide it here again. And now this piece here, I'm also going to hit Shift E, and I'm going to extrude it to 6. Now, one of the options that you have here, when you extrude something and it's touching something else, you can choose to add it to that part, or you can choose to make a new part. So a completely different part that's not connected. In this case, we do want to add it, and so it automatically adds it to that part. So now, and I'll hide my sketch again. So now we've got the baseline bottom part. Now, I like to make my parts in the same part studio, just because it's simpler. So instead of using, if you remember, we had our planes here, and the top plane, the plane that's marked top, is actually coincident with the bottom of this thing, and I don't want that. I want to make a thing on here. So I'm not going to worry about the planes. I'm just going to go, this is a flat surface, so I can right click on it and say new sketch. And now I'm making a sketch that's on that plane, the plane done by that. So now I'm going to hit N to switch to sort of an orthogonal view. And I'm going to do another half circle. And so this is again a constraint here. I'm putting this in the middle of this circle. And so now this point is constrained to be a concentric point with that circle. So I'm going to click here, and I'm going to go over, and I'm going to drag it over to here and bring it back so that it's constrained to be horizontal with that. And then I'm going to go like that, and it automatically picks up that second constraint. So click it. And so now I'm going to hit D for dimension, and this is going to be R5 as on the diagram. And I'm going to draw a rectangle, and once again, I'm going to click one corner that's constrained to here, and then I'm going to touch this guy and just sort of drag down a bunch, because I know it's going to end up down here somewhere. And as long as you're in sort of the general area, it will auto lock onto that, and click again. And one of the other things I'm going to draw is a point. And this, even though it's an arc, is still a line segment, so it has a midpoint. And I'm going to click on the point when it's on top of the midpoint, and that will constrain it to be in the middle, and it will stay in the middle. And the reason I'm doing that is because when I dimension now, I'm going to dimension from here, and I'm going to say this is going to be 50. And the neat thing about doing it this way is I've said, okay, I want this pendulum to be 50. If I decided to change this to be 4 millimeters, well, this is still 50. It doesn't change. This constraint still holds. You know, and if I made this 5.5, it still holds. So you can change these things around, and the constraints are a really powerful way of saying, I want this to stay, you know, I always want it to be 50 millimeters long. So anyway, so we'll do that. And then the other thing I'm going to do, and I'm going to do this the same way I did it before. I'm going to click here and click here and click here, and I'm going to hit extrude. And this time, what I'm going to do, I'm going to create a new object instead of adding one. And instead of just setting a dimension, I'm going to do the same thing that Doug does, which is up to face, and I'll say that face. And so now I've got a new object that's 3 millimeters thick, and is like that. One of the other things you can do with OnShape here in this view is you can switch to a perspective view instead of a parallel projection view. So it looks a little more like 3D. When you switch to editing sketches and things, it switches back to parallel perspective. So one of the things I noticed when I did this is, oh, this is a 2.5 millimeter hole, right? You click on it, it says diameter 2.5. So there's two different ways to handle this. I could, make a sketch here and draw a bigger circle and delete that, but I can also go back to the original sketch and edit it and say, yeah, let's add a circle here. So I'm going to click, it's going to constrain to this point here. And I'm going to make it 3.175 and say okay. Now it chose the wrong thing for the extrusion, but that's okay because like sketches you can edit extrusions too. So I'm going to delete that from the extrusion and then just add this piece, and now you can see that it has these parts, and you can add or remove parts from an extrusion just by clicking on them, or you can delete them from the list here and click on other parts, and you can edit things like how you're constraining it and whether it's an add or remove or whatever. So now we've got two holes. One of them's 3.175 millimeters and one of them's 2.5, and that's really handy. So and the neat thing about doing this is I can go back to here and say, yeah, we don't really want it 25, we really want it 20. And everything still works. It doesn't change anything. If you made it narrower than this, you would run into some trouble. But if I wanted that to be really wide, then I can make it really wide, and it doesn't. I don't have to go and recreate all of this stuff. And this is the power of what they call parametric modeling. You're muted, Doug, if you're talking to me.
John, I was just saying that you can do the same things with,
Yeah.
In Design Spark. You don't have to start over again.
Yeah, well, that's good.
Yeah.
So, and the other thing that, we're going to do here, we're going to create an assembly. And an assembly is basically allows you to put objects together and then add motion constraints to them. So I'm going to insert two parts here, part 1 and part 2, and click on them. And then, so these parts are here. You can't edit them the way you would in a part studio, but you can drag them around and stuff like that. I don't really want to drag them around because they're going to be here anyway. So to do motion constraints in an assembly, I got to say, okay, you create what are called mates. And so I'm going to erase part 2 here for a second, just hide it. And I'm going to create a mate right there at sort of the top of this circle. And then I'm going to show that and hide this one, and I'm going to switch to the bottom side of that one, and I'm going to create another mate right there. Okay, so now I've got two mates, and I'll show this guy, and both mates are on the same axis, which is the important part for a rotational or revolute mate. And so now I'm going to create a revolute mate by clicking on there, and then the mate connectors, you can click on them in here, but it's kind of easier if you've only got a couple to click on them like that. So now it's got mate connector 1 and mate connector 2, and I say okay, and I don't want to create a second revolute, so we'll do that. I'm going to hide these mate connectors so they don't muddy up the screen. Oh yeah, and moving it still drags this thing around, so we actually want to fix the base so it doesn't move. And so now you can see you can move this around, and it's constrained to rotate in that plane. this is really useful when you're building robots that have these kind of rotational parts, because you can test clearance. So you can say, I really want to be able to rotate that 45 degrees. And, you know, that's kind of approximately 45 degrees, but you can see it's going to end up intersecting with this part. And so let's go back to our model. And we'll do a little change here. And so I'm going to make a new sketch on the top here. And I'm going to take a line and I'm going to draw it from, constrain it to be on this line and constrain it to be on that arc. And then I'm going to grab this line and this arc and I'm going to say, you know what, those need to be tangent. And so as you move these things around, because I've constrained it to be a tangent, it will put it in a specific place. So I'm going to just put it about there this time, and we'll make a distance, we'll say 2 millimeters out, like that. And then I'm going to turn my planes back on, because I'm going to mirror that across this mirror line, which is basically something in the middle here. And the part I'm going to mirror is that line. And then I'm going to hit escape. And so now I've got two of them here. And if I change this one to be 1.8, well, that one changes too. And so now I can grab these two parts and I can extrude them. So you can either say 3 millimeters and we actually want to remove them, or you can say up to face, this face here, and remove it, boom. So now you've got that. And so now when we go back to our assembly, of course, the assembly is updated with that. And now we can do, you know, hopefully at least a 45-degree swing of this thing. And if it's not, you can just go back and change that dimension to be 2.5 or 3 or whatever and redo it, and boom, it just updates automatically. So that's, I don't use assemblies very much, but they are useful for doing that sort of thing.
Hey, John, hold up.
Yep.
There was a question.
So John, question for you. So when you're doing the rotation there, can you constrain it so that when it interferes, it stops and will not rotate any further?
So what you can do is you can edit the revolute and set limits of whatever. Yeah, so 39. So it shows you what these are. So this is 49. So we'll say 50. Actually, I'm not sure if that's, yeah, it's probably 50. And this one will be minus 50. Now maybe you have to go minus 50 and 50. Yeah. So now
But you've done that explicitly, setting the angle.
Yeah.
If you could set it so that when it actually interferes, it stops.
Yeah, I don't think it does that kind of detection. I believe you can tell whether or not it's there's something in either in On Shape or in an extension that you can get that will do that kind of, like, it'll tell you whether there's a occlusion or something like that. But no, it doesn't treat these as solid parts from that perspective.
Okay, thanks.
Yeah. So yeah, so when I build my robots, this is normally how I do it. I build in a part studio and I, you know, add parts one over the other, and you know, because you're really, you can think of it as the process of extending. You know, you build one part and then you extend it by building a second part, and those are printed separately. You know, these are actual different parts, part one and part two, and of course you can rename that. You know, I can say, okay, well, this is going to be base and this is going to be the Pendulum, kind of thing. And you know, you can export these as STL files, and you know, and just bring them into your slicer and print them. each of them. You wouldn't want to export the document as an STL because then it'll export this as basically one piece. And then of course, if you print it, they'll be stuck together. So you export them as separate pieces and then you can print them that way. So I don't know that we really have time for both of us to do like a full bumper here. So probably since Doug has got all of his parts and things together for a bumper, maybe we should switch back to Design Spark if nobody else has any questions about this. I'll just show you a couple more things that are nice with On Shape. Things like fillets are really useful. Whoops, not that one. This line here and that line. So so if you want to round something, or you can change it, and of course you can go back after the fact. I might say, let's put a 1 millimeter fillet on this, and it automatically goes and adds them, and of course you can do the same. Whoops, I don't want to do it on the bottom there. That's, wow, I have no idea what that just did. Let's just delete everything here except for the first one and click there. So now this thing is filleted on both surfaces like that. And you can do the same thing to other parts. And you can also do fillets on inner parts like that, and it automatically does a nice job of doing that. And you can also do chamfers, and there's, whoops, you have to be careful what you select here. I just want to chamfer this line. You can also do, instead of equal distances, you can do 2 distances. So I can say, this one is 5 and this one is 3. So it's going too much of a point. Yeah, it's almost at a point here. So so you can have it so that it's chamfering at not a 45-degree angle, which is convenient. And there's similar things for these kinds of fillets as well, although they get more complicated. There's different kinds of setups you can do, and whether you propagate tangents and variable fillet, there's all kinds of options. I don't use hardly any of these. I normally just make a fillet be a fillet kind of thing. So, and the other thing that you can do with On Shape that's neat is I can grab this rollback bar and I can go back here, and now anything I do doesn't include any of that stuff. So I could go and make a, let's make a new sketch here, and we're gonna make our put that somewhere around there. We'll make our oops, that's the wrong thing to drag. We'll put a hole in the middle of our thing here. We'll say that's going to be 35, and make that about 8, and then we'll grab that and extrude, and I'm going to just remove it. Now, we don't want to remove, I mean, you could actually remove it from both pieces if you wanted, but I don't really want to remove it from the base. So I'm just removing that from the pendulum, and then I'm going to add a fillet that's 2 millimeters to this inside corners here, and do that. And so now I've done that, and then I can grab this rollback bar and drag it back here, and all of those other things are reapplied. So you can sort of go back in time and work on it. Now, of course, if you do something that changes the model enough that the later operations aren't going to work, then that causes problems. But it's it does a pretty good job most of the time.
What's the rollback bar?
This big gray bar here. So you can grab it and you can drag it back, so that you're working from here.
Oh, from a previous iteration of the design.
Sorry, what's that?
You work from a previous iteration of the design. That's interesting.
Yeah. So you can go at any point in your design and roll this back and see what it looked like at that point. And you can also change the order of these things. So, like I added a fillet here, and then I filleted that thing, and you can change what order these things happen in. So I could put this chamfer up here, and that doesn't change anything about the end design, but of course sometimes it does, depending on what kinds of operations you're doing. Like if I took this fillet and changed the order with that one, then suddenly these end pieces aren't rounded and it turns red because there's an error, because there's an edge that we're not handling properly here. So
how do you get to show how do you display the rollback bar?
it's always there. It's right at the bottom. Just put your mouse on it. It says rollback bar. It's always at the end of the list if you're just operating normally. So your features list, it's always at the end of the features list. You might have to scroll it all the way down, but it's always there.
Okay. Yeah, I see now. Thank you.
So yeah, that's sort of a quick introduction to On Shape for 3D printing.
All right. So we'll get there. So what I was trying to get at the point is that that's a little test piece. Instead of printing out a humongous part, you make sure that this key feature is right before you incorporate it into your part design. And this prints probably within 2 minutes. So you can go in there and say, it's what I thought I had, go with it.
Highly second.
Yeah. So now, is that part ever used? No. It's just for making sure that hexagon sizing is correct. All right. Now, if you have Design Spark Mechanical up, who's got it up? Anybody have it up? Okay. I want you to design this or try to design this. If you have, you want me, and we'll follow along. All right. So we're going to go up here to the circle tool. We're just going to do 16. We're going to go back up to the circle tool. You don't have to, you can just draw it. And we're going to do 4. That's so far, that's the 2D view of what we want. So now you select the 3D mode right here. And now you have a surface. If you want to change the view to trimetric, you just hit this. Now you notice it automatically puts you in pool. So we want to pull 3. And the part is done. That's all there was to it. Now, we can get fancy. We can go on the end here. And on a pool, you see how the arrow is pointing inward? If you push it in, you get a number that you can put. So like if I want to put a 1 millimeter bevel on it, or I can go over here and pick a, what do they call that?
Chamfer.
Yeah, chamfer. I can go on the other one, pull it in. I can put a 1 on that. Now now you notice the top side is kind of rounded. And if you do a spin, you can see the bottom is straight line. So that sort of is a tool that's very cool. Now, let's say you don't like that. You can always go back and change it to something else. Let's say 0.5, and it will change it. Okay. And I think that's right. But, or if you always, there's other way you can always do it if you're really not sure, is you can make it go away and then just reset it. Probably the thing you have to realize is that you have to start the movement for the number, the dimension box to show up. All right. So, and like I say, I think what I did on the last one was I actually beveled the top part again. So you could do that. You could add a second bevel to it. So anyway, yes.
So for me, when we were starting this earlier,
Yeah.
doing Design Spark, it took me a while to figure out. I was trying to figure out how to pan, and for other people that are new, it's shift and then hold your middle mouse button down.
Right. Yeah.
And that'll pan it.
Yeah. Shift, middle.
Mouse button.
There's also a pan button up here, but it's just one use kind of. And so that's the thing. So now, one of the things that you really don't want to do is put bevels and stuff on. You don't want to put bevels and stuff on your part and then change the diameter, because the bevel will follow the diameter. It's easier to just click on it. And so, like right now, this is a radius of 8 millimeters. If you wanted to change it, you would put it in there. Like if you wanted to go to 5, it would be 5. Or if you wanted to go back to 8, you can go back to 8. Okay. So anyway, that's the first part. Did you successfully build this part?
Yes, I did.
All right, now.
He found the slow one, if I could do it.
Okay. All right. So now we're gonna go back and take a look. I got to stop sharing and go stop sharing and share and turn window. Boom, boom, boom. Okay. All right. Now I'm going to go to the next part. This one's a little more difficult. It's got a box in the bottom of it, and it's got this tab sticking out on the side and a hole. All right. This is because of where we are right now. This is going to be the end of the talk of these parts. Okay. So let's give this guy a shot. And unfortunately, I can't. When I share with the other things, you're going to lose these dimensions. So if you have the handout, you can go to the right page and get this. So this is really not, this is a fairly, this is a pretty nice little product. Now, if you 3D print this part, you're going to have to use what do they call it? Support. Yeah, you're going to have to use support, because you can't print out here on this tab. The printer, it's going to go around and around, and then it's going to try to go out here. Well, there's nothing underneath it. So your filament's literally going to sag.
Can you talk about how you do support?
That's actually a slicer function. So it's not, I don't know if you'd really call it, you wouldn't really do support. You can add support in here, Paul, by artificially putting it in. And my opinion is it's just easier to let the slicer do it. The modern slicers can do phenomenal things for support. They can be local.
So can you tell us what the support is? What does the slicer do?
Okay.
What gets printed?
What it does is, depending on your slicer, it puts a very loose matrix of material under the unsupported part. Okay. And when you get really close to the part, it blows air. So you actually have a thin gap between, so you think of it as there's a weak spot at the top of the support. And it's enough that when your filament is pulled, it won't sag there, okay? But you will always have a rough side on the support. The support very rarely breaks off perfectly clean, all right? And it can be real difficult if it's adjusted wrong to pull off of a 3D print. I mean, I've had 3D prints with support that, yeah, you just can't get it off.
So is it something that whoever's running the slicer needs to control? And so, like, if I take the design down to the STL down to my library, the guy who runs the printer is going to have to know how to do that support on the slicer, or is it all automatic?
Yeah, so you're going to have to know how to do it.
Okay, thanks.
Different filaments will bridge better than others. Like you can have.
Yeah.
PLA bridges very.
Right. For example, if this were a PLA part, you could probably put a few thin, narrow ridges here and here, and PLA could easily span this distance. Now with PLA, when you're printing it, you have a fan that's directed at the filament, and you're trying to freeze the filament as fast as it goes out. With ABS and ASA and other high temperature filaments, they don't bridge as well. And part of that problem is because you don't have a fan turned on, and you're letting the reason you're not doing that is because you want to improve layer to layer at his adhesiveness. And if you don't do that, you'll have cracks in your print. But PLA is phenomenal when it comes to bridging because of the fact that you're freezing it as soon as it comes out the nozzle. I don't think you could print this without support, even in PLA, because it's totally in the air. But if you gave it some little anchor on this end, some little place where it could hook onto, you could probably bridge all the way across that distance.
For the top layer,
Thanks.
make it thin. Do you get that in Cura? Because I've never seen that setting.
I'm sorry?
For the top layer where they make that part thin and blow a lot of air on it with the support, can you get that setting in Cura? The Cura slicer?
Okay, so let's say you wanted to print a box lid. Normally you would print it with the lid side down. But let's say for some reason you decided not to. Now, I don't know why you would, but let's say that's what you had to do. Well, now you got to bridge all the way across the lid. Well, when you get finished, it may look perfect on the outside. But when you flip it upside down, you're going to see that the bridging from one end to the other side was not perfect. And you're going to have like loose filaments and stuff that you have to clean off. But on that one, the answer is to print it with the lid down and point it up.
I guess my question was, you're saying with the supports, once they start reaching the top, it blows a lot of air to make that final thing.
What it does is it increases the spacing. So think of it as, let's say the overhang is at 10 millimeters. At 9.9 millimeters, the print actually stops. Okay, so there's a 0.1 millimeter gap. That's very small, by the way. And that helps for you to be able to break off the support material. All right. So now, like we look at this, it's got this square in the bottom. So we're going to print with the square on the bottom on the printer bed. That means the support is actually going to be in this area right here. Okay. If this bottom, if let's say I didn't have the hole in the bottom, one way I could if the design would allow it, I could have the underside printed at a 45-degree angle, so that it would be like a cone underneath and then flat on the top. Now, if the design would support it, then you could get it printed that way without the support in the center. So if you did it wrong, if you put this side on the bottom instead of this side, you would have to handle this area in here would have to be supported. And this is so deep that would be a real pain to get your support material out of. So you wouldn't want to do that. All right. Okay.
Hey, Doug,
Yeah.
I got to take off. I just wanted to show I printed a pendulum.
Oh yeah. Okay. Hold on. So while we were eating food, John was being busy and actually printing out.
Yeah.
Okay.
The
Wait a
model.
minute, John.
Yeah. So
I'm pinning you.
Yeah.
Ta-da! It worked.
Cool.
It's got an M3 screw. I basically tapped this hole with my actual tap.
Yeah.
And yeah, so we got a pendulum.
Nice.
Neat, huh?
Yeah, with a beer tap?
No beer tap. I think it was a real screw tap.
Yeah, it's one of these.
Yeah.
It's an
Nice.
M3 tap. So I just put it in my drill and.
Okay. When you're when you're doing a 3D print like this, and John, how many loops did you include on the outside?
How many? Well,
perimeter loops.
Let's find out. Where's
What
my?
are perimeter loops?
Well, I'm going to talk about that in a second. Go ahead.
I'm trying to find my slicer. It's not showing up for some reason. Just a sec. Let me share window. That's so weird that my slicer isn't showing up as in here. Well, I'll share the entire screen, and you'll just have to deal with the size. But this is my slicer.
It's showing up. Something's showing up.
Yeah, it's anyway, this is the slicer that I use because it's the one that comes with my printer. So when I slice, I have a normal thing here, and then you can preview it, and this is what it looks like. So you can see in here that there are there's basically 3 walls. I'm not sure how many.
No, that's what I was looking for. 3 perimeter walls.
Yeah, 3 perimeter walls, and there's 5, I think, on the bottom, and something 3 or 4 or 5 on the top. So yeah, that's what it looks like. And to answer people's questions about support, if I took this and I rotated it in the slicer by 90 degrees, which would be an absolutely silly way to print it, but you can, and then you look at it, then when we wind this down, so that's what support looks like. So it's basically a really loose set of filament that fills in the space enough that when it gets to the top here, then the first layer ends up being flat, sitting on top of that support. So you can see when it prints, the light blue stuff is support, and that just breaks off.
If you're lucky.
Well, with ABS, this works really well. I mean, like the thing that you were talking about, with the hole, I have no trouble pulling support out of holes. I just put because of the fact that the slicer slices, whoops, it makes these vertical lines with spaces between them. I can just take a pair of needle nose pliers and shove it in and just twist it a little bit, and it breaks right off and comes out without any trouble at all, even for deep holes.
That does work. So I've done that too. Yeah.
Yeah.
But I will
And
say that
does this apply to holes that end up having to be printed horizontally?
What holes?
Say holes, two holes at right angles. So one of them has to be horizontal. So there has to be
holes
printing
are no issue. You don't need support for holes. Like if I take this and I rotate it 90 degrees and then slice it, holes don't need support.
Oh.
The printer, because of the fact that you're building each layer on the layer before, it can do a certain amount of overhang without any issue. And so
Okay,
the holes
thank
don't
you.
generally, as long as the hole is round, it doesn't need support.
I'm
Thanks.
going to preface this a little bit. This is where if you're using an older slicer, you could get where they do put support in there.
Yeah.
The newer ones are smarter and do like what John's saying.
Well, I can adjust the settings on this, and I can adjust. It has simple settings and it has really complex settings for all kinds of stuff about, how to do this stuff. But I don't generally use that mode most of the time. I can just say slice all or support for all, and now it'll have support inside that hole.
Yeah.
So you can see that there's
Oh.
support printed inside the hole because I said make support for everything. So that's just a parameter you can tune in the slicer.
Yeah, but I'm saying some of the older slicers did not
Yeah.
have, you couldn't tune that part.
Yeah.
The new ones can do localized support. And, it's being driven by people who do these character models and stuff where you're always going to have some support, and they put localized support so that just areas of the model have support. But for most of the parts that we make, you're not going to ever need all that. You're not going to need that fine of control. But it's there.
Yeah, and I mean, this part needed no support because, of course, if you print it the right way around, then, with a flat bottom and the pendulum part is flat, so you don't need any support.
Right, and that's one of the things that, in general, if you can print a part without support, that's superior than printing one with support. You'll get a better finish.
Yeah.
I mean, but sometimes you can't do it.
Yeah. So like as an example, this is one of the motor parts for my balancing robot with a different motor in it. I print this in this orientation. It's not super strong that way, but it doesn't have to be because it's a very light robot. But it prints support inside here, and then it prints a bit of support for this tab that's not at the bottom here. And if you look really closely, that's kind of a messy edge or surface compared to these ones here, which are sitting basically on the print bed. But yeah, this is an example of one of these ones that has a deep hole, and it just prints that support like that, and you just click and out it comes, and it works really well.
Thanks, guys. That was real illuminating for me. I appreciate it.
Yeah, I got to run. I'll see you guys.
Thanks a lot, John.
Bye,
Really
John.
appreciate your presentation.
Thanks for sharing.
Yeah.
You can improve it with like fingernail file. That tends to smooth it off pretty good. You can use a regular file. I think you can use acetone
On it,
PLA. Right?
well, not PLA, AB, you can use acetone on ABS to smooth, but, it's messy and, yeah, the idea of a file, usually you can take, like an X-Acto knife and get it good enough. And like John said, you can reach down with, needle nose pliers to deep holes. You can do that, but if your material breaks off real easy, that's great. If it's one that's one of the tougher ones, you're still going to have a little bit of cleanup to do. But the bottom line is, if you don't have to do supports, don't do them. But on our part, if you remember, it's got support.
We cover brims and rafts.
Okay, so you're going to have support under here. All right. Now, there's some other settings on 3D printers that you can add, and like Ray just mentioned, there's a brim, and what's the other one?
Raft.
Raft. A brim is usually a good thing to put on the bottom, but you only usually need it on your floor layer, your first level. But a raft, what that does is it puts a kind of like a waffle type material underneath your port. And where that's really good is if you have, let's say you're trying to have a part with a really high aspect ratio, otherwise a narrow base and a narrow tall piece. A raft allows you to expand the base down at the bottom. And it's another case of where you're going to end up having to clean it up. So you have to look at your part and say, why am I trying to do a tall, skinny thing? Would a rod do better? You know, I have a real problem with people printing flat plates and tall cylinders. I mean, to me, that's like, why? All right, why would you do that? But I'm sure there are cases where it makes sense. Okay, so back to this part. Let's stop sharing. And why am I? I'm okay. Then I got to go back to here, and I'm going to share entire screen. Share. No. Okay, we're going to start a new file, a new design. Okay. All right. Since I've got one guy actually following along, I'm going to give him a chance. You got this?
I got the circle with the cutout. I've got everything except for the shelf. So that's
Okay. All right. So he's not only is he following along, guys, he's going ahead. We got us a winner,
I'm
guys.
sorry, I'm that guy.
Okay. What, Zach?
I'm that guy.
Oh, you're that guy. Okay. All right. All right. So we're going to start off, and this will help you figure out how you're going to do this. All right. So we're going to start off. We're going to draw a 24.3. And don't ask me why, but that's the way it is. And then the interior is going to be, let's see, what is the interior?
So 18.4 if you don't want to do more.
Okay, thank you. 18.4. All right. Now, so there's going to be that. Now the bottom is a 11 by 0.11 square. Now we're going to go over here and define the rectangle from the center. And we're going to go to 11.83 and tab and 11.83, enter. And there's our square. Okay, so now we're doing that. But we know this other thing is we have to make us a rectangle. Now, I like to do this. I would probably do this with construction lines because I want it to come into here. I want it to be at 90 degrees and I want it to be 29.87. Okay. And then I want it to be 22.15. Okay, now once I've got that, I can come up to the square and I can grab this guy. And there we go. We got, whoops. That didn't work. Looks like I'm off a little bit. So let's try 24.
Okay, so, hey, so slow down a little, Doug. Got a little hiccup here. So the first thing you do is put a construction line up on the top.
Yeah, because I know the dimension is 29.89. Okay, now when I was designing this, did I know it was going to be 29.87 or whatever?
Yeah.
No, I just put it in a rectangle there and then probably adjusted it in the 3D view. Otherwise, I'll show how that can be done. That's real easy. All you have to do is push and pull. So let's do that. In fact, let's back that off. That way I showed you would work. Okay. But let's back away. And I'm just going to say, I'm going to take away those construction lines. All right. I'm just going to take a rectangle. Got to get a rectangle. And do.
Oh, okay. So you're changing up how you did that.
Come on. Wait a minute. Oh, no wonder I want a construction line. Give me. Okay. I thought I clicked on that. So I would go to here. And I'd probably do something like that. Okay. So there, I don't know, it's just a rectangle.
So you just did a rectangle.
Yeah, just did a rectangle from the 2 points where I want it to blend into the circle.
A real rectangle, not a construction line.
Right. Now the construction line has the advantage that it's easier to put the dimensions in. Okay. But I'm going to do this because I'm going to show you how we do it and how we can adjust it later.
Okay, so question for you. So I'm drawing the square and I've got it, the rectangle, I've got it anchored on the top of the circle, but how do I get it to snap to the bottom?
You should be able to find the bottom of the circle. There should be a little circle there.
Yeah, I can find the bottom of it when I go straight down, but when I start to move over, it wants to move. And snap.
Yeah, that's why I do the construction lines. Otherwise, remember with a construction line, you only have to do 2 construction lines to define a rectangle. Okay. All right, but let's so now we're going to go to 3D mode, and we're going to put it in a trimetric view. All right. Now we know this guy, and if you hit Control, you can select a second region. We're going to go all the way up to 22.5. Okay. And the bottom there looks like what's the bottom dimension? Don't tell me it's probably not there. Oh, no, here, oh,
2.5.
2.5, okay. So now I'm gonna do a spin. Okay. Now I'm gonna you have to hit pull again. And I'm gonna do this, hit this selection and then the other side with a control. Then I'm going to pull up and I'm gonna put 2.5. All right, so that's the bottom. Now this bottom part, what about this guy and this guy? Well, that's supposed to be a hole. So I'll hit control and select both sides and I'll hit delete. Now it's a hole.
I did a little differently. That inner circle I did as a construction line. So I pulled up the bottom piece with the square already cut out and then pulled up the construction line and then made it wider.
Mhm. Now, okay, so here that works.
Yeah, it worked. I
Yeah,
was
so
just trying to find a way.
yeah, trimetric. Now, what about this guy? Was this the one you were having trouble with?
I finally have a square on there now.
Okay.
I don't know if the dimensions are correct.
Right, that's fine. So you hit it, select move,
Hold on, let me get 3D.
okay?
Okay.
Grab the black arrow, look where the top is supposed to be. It's supposed to be, let's see, looks like 15 plus 3, so it needs to be at 18. So the top is going to go to 18. Okay. All right. Now I'm going to do a spin. I'm going to hit pull. And I'm going to grab a 3. Okay. Now, we know this isn't the right length. All right. So I'm going to go back to trimetric view. So I know that the distance I can, if you look up here, there's a dimensioning tool and there is a measurement tool. For this, we'll just do a measurement. So I grab that it's not a face, what do they call it? Edge, they call it an edge. So I'm going to do select, by the way.
What
So-
was your dimensioning tool? Oh, I see. It's a little caliper.
Yes. Okay, so I'm going to select this edge. You need to be in select. Then you hold down control. You got to have it pushed too. And it says that we're the distance, minimum distance between those two edges is 160967. So at this point, I would say 29.87 minus 16.0767, whatever that number is. Anybody got a calculator real quick or? Okay, so it's 29.87 minus 16.0967.
27 minus
16.0967.
13.773.
13 point,
7733.
oh, okay, 13.77. That's good enough for me. So I'm going to do a spin so I can see that face. I'm going to do a pull, select, and I'm going to go 13.77. And there's my tab. So
Okay.
now you could, like I say, the first time we used construction lines, we didn't have to do this. Go ahead.
So how do you do the calculation you were calculating what your actual distance was, subtracting that from what you wanted to be and pulling it that much. Is that correct?
Yeah.
Okay, my numbers are different. That's why.
Well, that's fine. We're not actually going to use this part, guys.
And you don't have a way to do that by saying, I want to pull it and I want the distance along where you're measuring it to be exact.
I think it's always going to be the plus, plus or minus what you had before. Yeah. Now I got to admit there might be a hidden thing that I don't know about. All right, so you know, if we wanted, so now we need a hole in this. Now, see, guys, we should have put the hole in when we were in the 2D. So what we're going to do is we're going to select a plane and then go to 2D view. Now you see what it did is it cut it off right there. All right. So now, in this case, I probably use a construction line, and it's, how far is it? It's a 4 millimeter. How far out is it? Did I not? Anybody see where that dimension is? Probably didn't put it in there. Yeah, it's not in there.
So we put it anyway.
Yeah, so I'm just gonna put it right. This looks like a good spot. So I'm gonna put it there. Okay. Now I'll go and grab a circle. And I'll go 4. And there's my thing. I'll go to the 3D view. And I'll do a pull. I'll select that area. And I'm just going to run it through. And there's my hole. So now we have the part. Cool.
That's cool, Doug. Question: can you not go back and modify the 2D sketch and have it?
Okay, Paul.
Reflected.
There is a undo button. All right. And it has all of these things. I don't know. I got to admit, I don't know if see, there is a purge on it. So you might be able to get rid of it, but let's go back, create
Okay,
line.
that's fine, Doug. I didn't want to delve into that
Okay.
in detail. I was just surprised because On Shape will let you modify the 2D sketch and
Right.
then go back into 3D and work with that modification.
There may be a way, but I don't think it's obvious. I haven't used it that way. Now, I will say this. One of the problems with this is if you look down here, you can see I have a design 2 and a design 3 and a design 4. They all share the same undo list, which is kind of a bad feature. So like if I keep backing this guy up, the design we're working on undo, eventually I'll come to one where it was on another design. So that's not a good thing. All right. But you can do at this point, if you wanted to bevel these guys, you can bevel them or whatever you want to do. All right. It's often, if you're going to insert something, it's always a good idea to put a chamfer on the side where you're going to stick it into. So like if you're sticking these switches into the front of it, you want a chamfer on that edge so that it slides in easier. It self-centers. So you would probably do something like this. You would click on the edge. You would select. Yeah, I think this is. See, which one of these is chamfer? I think this is it. And you would just push in some amount. And that just makes it, I usually 1 millimeter is usually a good one. And that would make it easier to insert the switch into this. All right. Now, anyway, so did you get it?
I don't think I've got the link exactly right. Everything else.
Okay, cool. Yeah, make it yours.
So one thing that I did just find, so I did the subtraction on the calculator to see what I needed. And then when I did a pull and it opened, it lets you edit the number, but I was disappointed it would not let you paste the value that I cut from the calculator. So in other words, I already had minus, 4.55.
Yeah, you mean you couldn't pull it off of the clipboard? I don't know. I gotta admit,
Yeah,
I probably haven't noticed that.
Yeah, I did a control C one in the calculator, which should copy your results. And then when I control V with a number highlighted with a full number delta, it wouldn't paste anything.
Okay.
So I don't know if it didn't pull it out of the calculator or it's not taking the paste,
Well, it's probably not taking it from the clipboard.
which would be really handy if you're kind of trying to.
Oh, yeah. Yeah. So anyway,
Good stuff.
I wanted to say, okay, the learning curve on Design Spark to me is very easy and very intuitive if you're a person who starts off with your designs in 2D. I would argue even with On Shape that you should start in a 2D view and get as much of the thing laid out as you can. Some things I don't like about Design Spark Mechanical. This is the free level, and when they went to a paid level, they took a few features that had been traditionally in the free level out. And one of them that they did was the ability to import, not export, but import a step file. And why that it would be a handy thing to do is if you have a design done in Fusion 360, or you have a design done in something else, you could import it. Now, the only thing you can really import pretty much, I think, let's see what you can, let's see what's available. New, I don't know, open.
I don't even see an import on the file.
It's going to be just a file open, and you can have the design mechanical files, obviously. You can do bitmap. You can bring in a PC, a Design Spark PCB, which we're not working with, a JPEG and a ping, and a curve point. I'm not sure what that is.
With no STL.
Yeah.
So you can't really import anything in 3D.
You can.
Other than design.
I think that's funny. I'm surprised. You've always been able to. You've always been able to import an STL, but I don't see it on this. Now,
Just as a data point, Doug, it is possible in the free version of On Shape to import STLs.
yes, and they used to be able to do it in this. I don't know if this is a feature they took out. I got to admit, I pay because I'm using this. So since I pay, I don't have these limitations. It's really me, but I'm saying this is a big limitation of the free level. And this is one of, I think, the biggest advantages of On Shape is they haven't locked it down as much. Now, if you're willing to pay, I think it's $10 or $12 a month. You can do import and export step files. You can take an STL file and turn it into. You can make it a solid from the mesh. Okay. But you can also do that in FreeCAD. So it's a little more complicated, but it's something you can do. So I guess what I'm saying is it's an easy learning curve. All of the things you learn here, I think could be applied to On Shape because and what I wanted you to get in here was not to be afraid of these programs. Okay. And you can do it. Okay. Now,
I guess a quick question, Paul, on the On Shape STL import. Can you import an STL and kind of use it as a sort of as a template, not as a part of the drawing, but as a stencil, if you will, in case it's I'm thinking of like a 3D scan where it's not very good, but it's good enough to be able to use to kind of build your design on.
I don't know the answer to that. But to back up Doug's point, I absolutely agree with him that the concepts that he showed here in Design Spark are absolutely the same in On Shape. If you can do the things he's shown in Design Spark, okay, the buttons are a bit different, the mouse clicks are a bit different, but all the concepts are exactly the same as he showed.
Now, as an exercise, I don't expect any of you guys to do it, but if you could go through these two additional parts. They don't use anything new. All right. The one thing that they might do, and I'll show you on, oh, well, I won't show you, is where you have this angle here, you can use the move tool to create that slope if you want to. So what you do is you grab the edge and you move it down to where you want it, and it will cause it to slope. So now I'm going to talk about my favorite thing, 3D printer considerations. This is one of my two printers. I bought these from Hobby King in 2016 for a cost of $125 a piece, and which was cheap back then. So I felt, I got it. The overall design is what they call a bed slinger design. And what bed slinger means is that the bed moves. Okay, it moves in the X and Y condition. There's another method called a core XY, where the bed doesn't really move except up and down, and the extruder moves in the XY position and Z. Okay. But the bed slinger design is the one that Prusa uses, and everybody it's been, since they came back in probably 15 years ago, it's been like the standard. And why are they moving to Core XY? There's a couple reasons why they move into Core XY. Easier to put in an enclosure. Okay. They fast, very fast, because all you're moving is the print head and the extruder usually. So there's some advantage. One of the disadvantages of the Core XYs, it's very susceptible to vertical striations. They have a tendency to. But if you look at a vertical wall, it'll look like it's a little wave to it. Okay. All right. So I'm going to go down these to talk about how this compared to a modern one. This is a direct extruder. Well, it's really interesting. The direct extruders were heavy because they have a stepper motor on them. So 3D Designs went to move the stepper motor off of the x-axis and used a tube, Teflon tube, to feed filament. Well, it turns out that over time, the good printers have gone back to what they call direct drive extruders, because the other ones just first of all, they couldn't do TPU, which is like rubber band material. And there was a couple other problems with it that it turns out the direct drives. Now on mine and all of the standard reactivity ender ones, it's a single drive wheel on the extruder. Modern machines, because they're pushing so much filament, have gone to what they call a double extruder. Okay. And why am I telling you this? Because if you're out there going to buy one, you kind of need to know this stuff. All right. Mine, you notice there's two rails on each axis. See them up there and over here on the Y? Well, the top line ones use linear rails, much superior. Okay. The ones that are kind of, I think this is better than the alternative of some of them. They use what they call POM wheels, POM. And it's a little rubber wheel that runs inside of an extruded aluminum channel. And I think they're more problematic than these dual linear bearing type. All right. So it's dual steppers on Z height. Otherwise, on behind this bar and this bar, there's a stepper with a Acme lead screw. Now, this is another one of those things that this is the way they used to make them. Then they went to a single screw and single stepper motor, and it was a cantilevered design using palm wheels on the other side. And that got to be kind of the cheap way to do it. Well, you know what they offer now? They offer dual axes stepper motor upgrades. So now what's happened is people are putting in a second screw and stepper motor to overcome the problems that you have when you have that big cantilevered X-axis. Okay, this one has a very simple little box fan that's directed at the filament nozzle. Modern ones have two directional tuned fans that, you know, blast cool that filament immediately, and as soon as it's out, it's hard. But if you're using high temp stuff, you're not going to be using the fan. But that's what you have. All right. Okay. All metal construction. Before this, these printers, they had a lot of plastic in them. Pretty much now, almost all of it's going to be all metal. So that's stayed the same. This one had an 8x8-inch bed, and they've slowly creeped up to now where they're up to about 10 inches.
You had like reinforcing rods in front of that.
I did, because when this came out, people hit it with a gazillion upgrades, and I was my new printer, and I could print things. I had to have something to print, so I printed every upgrade I could find. And you can see I have red one, and the other one's in white. Yeah, there's a lot of upgrades. If you look, I don't know if you can see them under here. These little wheels that you adjust the plate. They were made bigger. This guy used to be straight up like this, which makes the viewing angle. There's actually on this one, it's tilted. There's a little, I think you might see it on the next picture. And like you said, there's these front ones. So anyway, top mounted spool, much nicer than some of the newer designs are actually putting it behind the machine, which is absolute nightmare. Okay. So this was a good thing. The way this is configured, that's actually a magnetic bed. So you know that stuff you get from your insurance broker that has this card stuck to it, and it's like a magnet plate. This is actually on top of the metal bed, has one of those sheets glued on, and then it has a second magnetic sheet that has kind of a slick finish that's put on the top. Now this type of bed is kind of gone out of style. They have a new type, which is on the enders, which use individual magnets, and it sticks on, and that allows you to go to higher temperatures, because above 90 degrees, this thing starts to demagnetize. So it means you're not going to be running ABS on it. Okay. 1.75. I can remember when all the printers used 3mm stuff, but nowadays everybody's 1.75. And why is that? Because it allowed them to go to a non-geared direct extruder. The old printers had a big gear that drove the extruder screw, and that extra torque was needed to push that 3mm filament down. Now, what's the advantage of 3mm? You don't have to push as much down. All right. So they've 175, that's the only one you should consider. There are still a few 3mm machines available. Don't buy one.
We got one here.
Yeah.
We have a-
God, I wish I'd known. I gave away a whole pile of 3mm material. Let's see. This one uses Martin software, which is an open source software. You won't see that anymore. There's much better options.
Is it supposed to be Merlin?
Marlin. Yeah, it's Marlin. I'm sorry. I spelled it wrong. It has an M3 style hot extruder is not the right word. M3 hot end. And these M3 hot ends were one of the first ones that came out by MakerBot, where they discovered that you want a real strong heat break between the extruder and the hot end. So you want the hot end to be really hot, and it's right above it, you have the extruder, and you want it to be really cool. Well, they use the properties of stainless steel, and what they do is they cut a narrow neck into the screw that goes from the hot end up to the extruder, and that acts as a heat break. Let's see. This one was another thing that I didn't like. It has a micro SD card insertion, which was a pain in the butt. So I use an SD. I do all my things by just bringing an SD card and plug it in. So I have a micro SD to SD converter. All right. Now, what about what about ABS and stuff? Well, this was the kind of the changes you had to make. For
USB port?
Huh?
Does that have a USB port? Because I plug a 5.0 in mine.
I don't think this one has a USB port.
Okay.
Yeah. You have to have, if you're going to do ABS and all of the really interesting filaments, you need an enclosure. Because if you don't, they'll warp.
That, I guess, toxic.
Huh?
That and ABS is toxic.
Yeah, ABS is toxic, and you can see this is enclosed, but there's no filter on it or anything. And so this is, I'm probably breathing a whole bunch of nastiness. So that's one of the reasons why I don't use ABS anymore. I use ASA. It's more expensive, but it's a lot better. It doesn't stink either. The other thing is this one has a different print bread. This one just actually has a borosilica glass plate, and on top of that glass plate is blue tape. And on top of that blue tape, if I were doing ABS, it would be glue stick, but with ASA, it just sticks. So that, and the final thing for high temperatures is an all metal hot end. Okay. Otherwise, you don't want, a lot of the hot ends have a Teflon tube that goes partially down into the top of it. It's above the heat break, but it still eventually will break down, especially at the really higher temperature. I have to run ASA on my machine at 260 degrees. And the reason for that is because I don't have enough oomph in my extruder, since it's only a single screw extruder. If I had double screw, I could probably do that. All right, so now that's all cool. But Doug, that's 2016. So what are we doing now? These are probably the most interesting 4 printers that are currently available. Now you can buy more expensive printers, but I'm going to say that they would cost you so much that you would feel pain. But not everybody feels pain at the same level. But these are, you can see there's 2 bed slingers. There's the Creality SR-C SE, which is completely configured up to handle high temperature parts, but it doesn't have an enclosure, but it can handle it. It's got the all metal, it's got the hardened nozzle, it's everything you need. The Bambu A1 comes, if you buy for an extra $150, you can buy a 4-color printer, and that 4-color change printer mechanism, and that is really cool, very, very cool. But it's if you're making robot parts, probably not necessary.
Having been doing this a very long time, I think a very long time, 2015. That AMS, what that's called, its name is Light. That's the layer, light version of it. I don't. If you're going to buy an A1, which I would highly recommend, go ahead and get the material handler thing with it too, because it's a good deal. It's a great deal when you get it. And if all you ever do is put 4 of the same color in there, guess what? You've got 4 spools of the same color, and it knows how to just keep printing and printing and printing if that's what you want to do.
And
never.
Yeah, I gotta admit, what I'm trying to tell you is, it's cool, but do you need it? You don't absolutely need it, but if I was to go to buying a Bambu, I would definitely get it.
Does it have an enclosure? It doesn't look like it's got.
No. So now we're going to move. Now the other ones, these are the Core XYs. Now this is a Creality K1C. C stands for carbon, I believe. So it's supposed to be able to do high temp stuff, and it is. It's decked out, and they improved it. Do not buy a Creality K1. They were a piece of crap. With the K1C, they fixed a lot of their problems, and it's competitive. And if that's the amount of money that you have, that might be a good deal. Now, I'm not sure which, I'll talk about recommendations later. All right. So then this is the Bambu P1S. There's another one. I think it's called P1P, but you want the S version because it has the enclosure and it has all the high temperature things you're going to need. You can take a normal Bambu P1 and you can upgrade it to an S, but it's going to be more costly. And again, it comes with the 4, you can have the 4 colors. That's $850. And I'll be quite honest, I am that far from pulling the trigger
That's
on
a great deal for that printer and everything you get with it. How it works.
Yeah,
You jump up to 12 or 15 for the X1C. They're king above that one right there, but you're not getting that much more than what you are getting. There's only a half of 1% of people that are going to want to print 16 colors. It's just not going to.
What's the print that size on?
They're all 250 by 250.
yeah. So and on the Creality printers, they're all, I can't say that. I'm not sure on the K1C, but on the CR10, it's 220 by 220. On this one, I think it's 220 by 220.
They're all somewhere right around. They're very, very similar.
Yeah.
In sizes.
Yeah.
Like that Creality might be in the 300s, but
Yeah.
I might be confusing that with Max. They just dropped the K1C, the Max version they're closing.
Yeah.
That's a 350.
Yeah.
You think?
Yeah, that's the max, and that's another more money. I would say this on the biggest problem with the people hate about the P1S is this little display, but there's display upgrades. All it is money, guys. All it is money.
I don't know how much, because I have that A1, right?
Yeah.
This software interface to that, where you're sitting on your PC, I think I might have touched that interface in the last 2 months. I've owned one of these things. I've touched it a total of maybe an hour, and it's at 20 seconds at a time that I need to see a temperature or a thing, or replace the filament or whatever it is. You use it it's not that big a deal. If that's going to stop you from getting that, it should.
No, I'm not just saying, but we got to make sure that everybody doesn't think it's rainbows and lollipops.
They all have their issues.
Yeah.
Is the upgrade, when you say you can get a bigger display, is that Is
It's,
that from
it's,
Bambu or is that, you know, there's?
I think it's third party. Um, so I don't know about, like I say, on the K1, they had bad vertical waviness. K1C is supposed to fix that problem, but I have seen a few reports where they say it's still there. I don't know about the P1S. Now, I'll tell you this. In the past, many years ago, I had an XY or a Core XY printer, and I never was able to tune that out. And I mean, I tried and tried and tried and was never able. So it's just, I think, a artifact of that particular design. Now, you got to remember, compared to my 8-year-old printer, you know, these things are fantastic. And like Harold was saying, the Bambus, and I would say even the Crealities are pretty much print out of the box. I mean, you put something on there, you should be able to print something. Now, doesn't mean that there's a zero learning curve. It just means that it's a lot flatter.
Even with the A1, where I got that in a box, you have to sort of put it together, which means you have to slide the bed slinging part inside the upward frame. There's essentially 12 screws you have to bolt in. They have a sticker on them with a green mark around the hole where you put the screw in, telling you where to. Even give you Allen wrenches, nice T-handled Allen wrenches to do all the work.
Yeah.
So it really well laid out. So is your mother putting this together? Well, maybe not, but it's pretty darn close. And
But her son-in-law probably
Yeah.
could, right?
yeah,
Harold,
yeah,
her son-in-law probably
yeah,
could.
son-in-law could, yeah.
Yeah. So anyway, I think right now, if somebody were to say, what would I pay for a printer? I would say any 4 of these will get you okay. But like I say, I've had wonderful fun with my 2 printers for 8 years. They've worked consistently for me. Do I absolutely need one of these? No, but
The Malin 150 is a tank.
it might be time to get a new printer for me.
Yeah, which printers do you have that were the 2 ones that were 8 years old? For the 2 printers that you had that were 8 years old, which printers did you have?
They're the Malin M150.
Now, I personally had an experience with the Creality K1C.
The CR10? What?
No, the K1C from Creality.
Creality has so many different models. I really can't tell you, and what I'd have to look at it. So we go through them. Like, let's look at this CR10. Okay, it has a high temp nozzle, hard. I think it's iron, steel, and it's capable of going up to 300 degrees. It has dual things. Now, all of these things in some combination on every Creality model. And you can upgrade most of the models too, because they're just kind of like, well, okay, we got this basic Ender 2 and we're going to do this to it. And then they had the Ender 3 and they're going to do this with it. And then they had the CR10 and there's lots of different things you can do with that. But the things you're looking for, dual axis Z, high temperature nozzles, dual wheel extruders, print bed, auto leveling. Now, auto leveling is a subject. You know, I've been running my printer for over 8 years and the printer before that one. And there comes a time when leveling a printer bed is just very simple. I mean, you can run a test print and you can look at it and say, oh, this screw needs to be adjusted. But auto leveling, I think I want to make sure my next one has it. So I never have to worry about it. Now, what is the good? That's the good thing is you don't have to, you just have to get close and it'll handle it. What's the bad thing with it? Is it's got to go out and check the auto level every time. They don't let you say, well, I'm going to auto level it and then not auto level it for 10 prints. They don't let you do that. So they always, so that adds like, you know, I've got this super fast printer now. It takes 11 minutes for it to auto level. It's like, holy crap, why am I doing that?
It's like on the Bambu, you have a 2 or 3 minute print, but it takes like 7 minutes to print it because of all the leveling, cleaning.
Yeah.
Yeah, but it does all those things. I was just telling John here. And it does all of these, most of these printers you have up here now, because they have a system in place and we just haven't built them up and kind of put things together. There's a system, so it tracks things for you. It does all any one of the things up to and including that. Oh, by the way, you need to, I can tell because they've got resonance sensors in there, so you can tell when you shake it. That they can tell, oh, you need to check the tension on your X belt or your Y belt. You need to check these things. It'll alert you to those things, which before, because very folks who know their printers well, like Doug and myself and everything, you can look at that test print and go, oh yeah, that's a little out of tension, or I need to adjust this a little bit. But you have to work on it to get there. Most people don't do that. The other thing that it does for me, it whined to me the other day. It said, hey, your Y rails need oiling. It's been a while since you've ran and you need to lubricate your Y wells. Please indicate that you've done this. And of course, it doesn't know whether I did it or not, so I could just hit the OK button and go on and be that way. But no, it keeps and reminds me of all those things. It reminds me of cooling things down and getting the filament out of the hot end. It has all those processes in place that me being very lazy probably doesn't do every time. So it makes it more consistent experience for people that are not used to doing this.
So I'm going to sum this up. Creality is the current Ford. All right. Nice, solid. There's a gazillion variations. You got the money, honey. They can go from dirt cheap to pretty expensive. And Bambu is the new kid on the block. Whiz bang. It's proprietary. So you not only you better work because you ain't going to be able to do anything about it if it doesn't. So it's something that you have to think about. But it is got tremendous reviews. They seem to make a truly quality product. And yeah, I don't think with any of these printers you could go wrong.
I agree with you.
Okay.
Absolutely.
Now, one last slide.
Isn't that kind of the biggest, a lot of the biggest complaint I see is it's closed source and, you know, Bambu,
Yeah. Well, I can tell you like Micro Center is shifting more. There's probably more profit margin in it because the costs are higher. And they are shifting more and more to Bambu printers.
In fact, if you want to go to Micro Center, get up and leave right now. Go down to Micro Center, go buy any of those printers on it.
Yeah. I actually took the picture. I actually took the pictures and got the prices from while I went down there. Now the Creality Ender 3 V2 was like I say, a good printer for about 5 years ago.
That's on mine. That's my first print.
Yeah. Now it might have been called an Ender 2, but you know, all of these are the same. So they've, you know, you can see here, it's a cantilever design. It's a single drive motor in the Z. It's got a twirl and click interface.
Black and white, too, not color.
Yeah.
Is it color?
Yeah. And in fact, if you go grab the Jerry's firmware set and load it on you have to load it into the printer and the controller at the same time. Turns into a very nice interface, very capable.
Yeah.
There's so many modifications for the things.
Yeah. It's just, and back to your point, Doug, you can upgrade the hell out of this thing.
Oh yeah. I mean, I've actually have pursued that once because I think I have a Creality Ender 2 version 2 sitting in a box somewhere, you know, that I never even took out because my other printers just keep on printing, you know. So now But, so that's it. That's all I had on printers. I thought I'd clear this up because that's probably why you're learning CAD. You're not probably going out here using the CNCs. Huh.
The PCB place that they can make your parts, send them the SPL.
Oh, yeah, that's true too.
One other point, this is a fine printer that you're showing right here. In fact, that's say it's my backup printer. That printer will max out somewhere around 60 millimeters a second at its print. The A1, which is not bad. The A1 there, the A1 that we're showing, the lower end of the other cores, there, that thing runs about 200 millimeters a second. If because of the speed and stuff, that's what you could turn it to. Those, the Creality and that P1S, they'll run up to 500. And they've been rated that way, and they've been designed that way and built that way.
Yeah.
So, the thing that takes an hour on this one right here will take 15 minutes on the other one, plus your 7 minutes of run-up time.
Something I'd like to add.
It's a significant difference.
Something I would like to add is, you said this was like about 5 years ago. There's a much more recent version. It's the V3SE or the V3K.
Yeah.
Super cheap.
Ender comes out with a new version. It tacks a V3 2S 157 about every 6 months.
Yes, but the nice thing about the V3SE, so I got mine for around 160 when it was new, and so it has a lot of nice upgrades like the auto bed leveling and the dual Z. It's not true dual Z. It uses a belt, so it's not two steppers, but it's one with belt. So it has a lot of those upgrades, and it prints a lot faster. Have a maximum speed of 250 per second. So if you were to go the end route, the V3 is a good choice.
Yeah, and by the way, I think there's 4 or 5. Okay, this is the lowest, and I think this is the highest bed slinger they offer. So between 270 and 130, there's probably 5 or 6 Creality models in there.
If you look real close in Micro Center, you can get someone get $100 off one of those.
Well, another reason why I brought this up, because I'm hoping myself that the Labor Day is just around the corner. If they knock off $50, they got a customer. So, yeah.
This is a good print to start with. Like mine now, I put linear rails on the Z, linear rails on the X, and I put another Z axis, so it's really stable. And then I've moved the extruder onto the actual.
Yeah, you got a direct extruder.
Yeah. I need my linear rails because I'm being this in the way that like bending.
Yeah, and you can get all of those linear rail upgrades. They're all available. You know what I mean? So, but when you get finished, you probably would be better to get this guy.
Oh, yeah.
Right here. I mean, from a money point of view.
If they come out with the one down upgrade, I would wait.
Yeah. So anyway, that's it, guys. I hope you've, like I say, decide to do, I would say go ahead with the On Shape if you can pull it up. But if you really want the smallest learning curve, probably Design Spark. So both of those programs are reasonable, and anything you learn, and it's really the methodology. Once you do that, they all are very similar, except for Fusion 360, which is different. So anyway, cool.
Hey, thanks very much for a great presentation, Doug. That was fantastic. And I learned a whole lot. So thanks.